ask all the great questions. Okay. Where to go? Sorry. 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 All right. Linear inequalities. Back in the day, you have done inequalities before, but they were usually on number lines. Remember, here, let me just throw your Wayback Machine. Where x is greater than 5, remember you would draw a line, you put an open circle there at 5, and you just color the arrows in. Okay. This is different in the sense that you have a graph and you've got linear equations that have 2 letters in them. We're going to ignore number 1 and number 3 right off the bat because we'll get to that in a second. Okay, but we're going to look at this one. This is just like a linear equation in what form? Slope-intercept form, correct? So if you struggle graphing linear equations, this is not going to be an easy stint for you. So, but if you just follow these simple little rules, I believe there's a lot of little idiosyncrasies, but it's really pretty easy in the end. So let me give you this to you. Step number 1. Graph the line like it is a linear equation, which it is. I can't figure out what I just did. Like a linear equation. So, pretend that this less than or equal to sign is just an equal sign. If I had y equals 2x minus 3, how do I graph that? This is my y-intercept, -3, correct? 2 is my slope, which means it is 2 over 1. Let me make this a little bigger for y'all. Okay, so from this point, I go up 2 over 1. It's positive slope. No, no, no. How's that? That's too big. That's too small. Anyways, so remember it was up 2 over 1. So here's my line. So this, ladies and gentlemen, is my line. And it's going to be on your graph there, but stop, don't draw it yet. Okay. Here is idiosyncrasy number 1. We'll ask you here. If it has an equal sign with it, which this one does, because there's that little equal line under there, it's a solid line. If no equal, it is dashed. And you can use your ruler. You could have gone ahead with what you're doing. Because of this equal sign, because this has that little line underneath the less than symbol, it will be a solid line. So it will be this. If that equal sign would not have been there, you just make this a dashed line. If you need to know how to draw a dashed line, it's simply this. Line, 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 line. Maybe you've seen dashes before. I don't know. I don't want to assume anything. Are you with me so far? Okay. Now, here is where even Elijah Fisher may have some trouble. Okay. Because when you graph this, you are looking for all the values of y that are less than or equal to this. It's not just this line, it's an actual whole part of the graph. In other words, when you see a linear inequality, you are going to have to do some shading. And that's where people run into trouble. Okay? But when you shade, you only have 2 options. You are either going to shade above the line that you drew, like this, or you are going to shade below the line that you drew, like this. One of those 2 things is going to happen. And your job is to figure out which one it is. That's my dramatic pause for suspense. What tells you this is this? See this little sign here? This is a less than sign. If you see a less than sign, you go to the bottom of the line. Okay, because you are shading where x values get lesser. And that starts right here and goes this way, lesser. That means you do not shade. This one should not have the top shaded, only the bottom, because y is, don't worry, trained professional here. Okay, and we might as well write this down. If it is a greater than sign, you shade the top part of the graph at that line, where y gets bigger. Y gets bigger. And that, ladies and gentlemen, kind of is it, except for when we get to a couple hard ones. Just graph the linear equation and shades. That's all you got to do. The only issues are, is it a dashed line, isn't a dashed line, and what side of the line you graph it on. So let's forge down. We're going to skip this one for now because it's slightly confusing. This one again. So graph this one, number whatever. I wish I would have put a greater than sign there. Notice there's no equal sign on there. So when you graph it, it will be a dashed line. And it works just like this. Crosses the y-axis at -1. It is a negative 5/3 slope, which means it goes from that point up 5, 1, 2, 3, 4, 5, over 3 this way, because it has to be negative. It is a dash line, so you go bang, dash, 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 dash with your ruler. Mine's not so straight. And then because it is a less than sign, you shade the bottom where it keeps getting lower to the other side. Doesn't matter what color you use, you are going to shade this. How about that? Fun and exciting?
Sure.
Now, let's look at the special cases here. Number 3, notice there's no x there. So y is less than or equal to 0. Where in the wide, wide world is y 0? Jaden is going to say, besides here, where on my graph is y 0? Here's the y-axis. Where is 0 on the y-axis?
Right in the center.
It's called, what do we call that, by the way? Thank you. Somebody do that. Origin, yeah. Okay, y is 0 right here. But where else is y 0? Okay.
Where x is 0.
If I told you to plot some points, for example, 5, 0, is y 0 there? Yes, where is that dot? 5, 0. If I said plot point -2, 0, where is that point? Right here. At -2, x is -2. Y is 0 every place on the x-axis. It's colored in, so you have to do this. This is where y is 0. It goes right there on that. And a note to yourself is, if it's just a y, it's going to be a horizontal line. People get mixed up with that and think otherwise because the y-axis is a vertical line. But if you're looking for y is always 0, it's always going to be on a horizontal line. And then guess what? This says y is less than or equal to, so I have to shade it. What part am I going to shade on that? Where are the y values getting smaller? Elijah? No, that's where x gets smaller. Left is not the correct phrase. Okay? Don't say left. Left doesn't.
No, below.
Below, underneath. That's where all the values of y keep getting smaller on this side. This is the graph of y is less than or equal to 0. If it would have been y is less than or equal to 8, boys and girls, kids of all ages, if this was what you were graphing, I should go to a pen. That means here at where y is 8, which would be here, what, 6, 7, 8, it's a horizontal line there, and you're shading below that. If it was y is less than or equal to -3, it's a horizontal line here, and you're shading underneath it. All y equal ones, if there's no x in it and it's just a y, it is a vertical line. With that being said, children, maybe you can make the deductive leap when we go to that first one there. If it's a x equals 1, guess what?
X equals.
It is vertical. If x is greater than 5, here where x is 5, it is a vertical line. And why am I making this a dashed vertical line? Because there's no equal sign under it. Okay? Because there's no equal sign under it. X equations are vertical. And here is the only time you don't think bottom or top, because there is no bottom or top to this, it's right or left. X has to be greater than 5. Elijah, I'm going to let you feel this one. On what side of this dashed line am I going to shade? On what side are the x numbers getting bigger? There you go. Look at him. See, he lives and he learns. Lives and he learns. All right. That shade justice. How about that? Is that not probably one of the single most exciting things you'll ever do in math? Now, let me give you, I'm going to give you a piece of your homework paper. I want you to try one before I go to one more small little wrenchy sort of thing. A lot of small wrenches in this thing. And I want you to go ahead and do problem number 1. Do el problem number 1. Those of you that are not in Spanish, that's 1. People like this because they get to shade. For those of you that have that artistic flair, why do you laugh at that? Truck drivers are required to carry flares. As with the people in their tractors. Number 1. Give me number 1 there. They give somebody good ones. By the way, it's going to get a little more exciting these next couple of days. I said number 1, right? What? It should be done. No, it takes very little longer than graphing a linear equation, which is not. Done, completed, finished, kaput. Happy with what you got? First of all, y is greater, so you better have shaded the top. Alright, so all you got to do is graph this. Positive 3 has a slope of 8/5. I can't get 8 by going up, so I'm going to go down. 1, 2, 3, 4, 5, 6, 7, 8. It is positive, so I need the line to go up, so I have to go 1, 2, 3, 4, 5 this way. It is not an equal sign, so it has to be a dashed line. Technically, you should put arrows because it goes on forever. And then y is greater than, so you shade the top side. Greater than is top. And it looks as such. Stop me there, ask questions, say, hey, I don't know why I did this. this or what happened there. That's the way it should look. In a bright, living color. Tavarik is going to say, how could it possibly get any harder? I'm glad you asked, Wayne. If you look at problems number 13 and 14 on your paper. Oh, Brooklyn, I'm so proud of you. Brooklyn said it. What's different about these two?
Standard notation.
Standard notation. Okay, I need you to focus just for 30 seconds longer. Standard notation is exactly the same with one exception. And let's do the first one first, and then I'll tell you the exception, because it comes on the second one. You graph this just like a linear equation, so I'm going to do what? Cover up the x, or cover up the y. X is negative 6. Everybody's good with this? Cover up the x. Y is, somebody? Negative 2, right? Because that's negative, divided by positive. Is it going to be a solid line or a dashed line? Solid, because it's equal. Is y, is it less than or greater than sign? Huh? So less than, so I'm going to shade the bottom. So what you're going to say, well, that's no different. Alright, here it is. I am going to make this incredibly large for you to see. What do you see there?
Negative 3y.
Alright, listen very carefully. This will save you many, many, many long, incorrect problems. When you're graphing in standard form, if the y term is negative, you have to flip this around and think of it as the opposite. Okay? If the y term is negative in standard form, instead of thinking this as the greater than sign, you have to think about it the reverse way. Because y needs to be positive, and to make it positive, you just need to make everything its opposite. And that's why. You don't have to actually do it on paper. You graph this the same way. It's going to be the same line you're going to graph, except when you shade it, the only difference is, instead of shading the greater than side, you are going to shade the less than side. If and only when y is negative. X's don't matter, the other numbers don't matter, only the y term. Let's see. So when you graph this, we graph it just like we did that last one. I don't know if it's going to end up being the same graph, but it's done the same way. X is negative 6. Y is positive 2, because it's a negative and a negative. Wait, did I do that wrong? Sorry. X is negative 6. Y is positive 2. It is a solid line, but here's where the wheels will fall off if you don't remember. Since y is negative here, instead of shading the upside, which is the greater than side, you shade the downside, which is the negative side. So whenever you graph one in standard form, that should be your first look and think, is that a negative? If y is negative, you're going to think the opposite. How about that? What do we got, 15 minutes? You may be able to do all these in 15 minutes, do you think? I mean, it doesn't take very long to do. And you may want to, after a bit, say, hey, would you look this over, because I'm not 150,000% sure that I got this right. I am